Let's look at the two-sum problem, which is a very classical problem now. So we have solved this problem using dictionary in the ON algorithm. So also we have practiced some problems using two-pointer sliding window method. Here, the purpose is to give a solution of this classical problem using two pointers and comment on the extensions. So first I will go through the statement of the problem, and then I will work out an example, and finally we will write the code. So the problem states that given an array of integers, numbers, and an integer target, we want to return the indices of the two numbers such that they add up to the target. So the condition is that the two numbers adds up to the target. So we may assume that each input would have exactly one solution. So this actually simplifies the problem a little bit. And we may not use the same element twice. So here we can return the answer in any order. So here are the three examples. Before we look at the example, let's first look at the constraint. So the length of numbers can be up to 10 to the power 4, which means if we use a n square time complexity solution, some test cases may not be okay. So the third constraint and the second constraint is about the nature of the element in numbers and the range of the target variable. So from here we can see the numbers and can be negative. So it emphasizes again there are only one valid answer in this problem. So next we are going to look at the examples. Before we look at the example, we want to mention that the method we are going to use is a standard two-pointer sliding window method. So the condition to check is that the two numbers sum to target. And here one thing to notice is we return the indices, not the numbers. So let's look at an example. We want to also remark that the numbers itself is not necessarily sorted a priori. So in order to use this two-point sliding window and to check the condition, we need to first sort the numbers. So in example 1, we are going to look at, so the numbers is actually already sorted. So numbers is 2, 7, 11, 15, and the target is none. Right. So the corresponding, let's see, if we initialize from two pointers, let's see, L equals this, R equals 3 in this problem, then we want to check what's the sum of the numbers corresponding to these two pointer. So see 2 plus 15, which is greater than none. So in this case, we are going to shrink R by 1. In other words, we try to make the numbers approach the target, right? So then after this, we get L equals 0, R equals 2. Then if we check the sum of the corresponding numbers again, which is 13, greater than none. So in this case, again, we are going to shrink R by 1. So now we have L equals 0, R equals 1. Then in this case, we have 2 plus 7, which is 9. We are going to return 0, 1 or 1, 0, corresponding to the requirement in the problem. So similarly, in this example, it has some points yet to be demonstrated. For example, if the numbers sum to a value that is smaller than the target, we need to increment the left pointer by 1. So yeah, that's about the example. So now let's write the solution. So the first step is that we want to do the sort. So, but in order to, we are required to return the indices. We need to remain the indices of the course numbers. So, for this purpose, I'll introduce a new variable. So, which is called, let's see, so to track the indices. So y and I for I y in enumerate numbers. So then we do the sort. We sort this the guy in place. So next we are ready to do the sliding window. So for this purpose, let's initialize the 2 pointers. One is from the beginning and the other is from the end. So it's length numbers -1. So now we are going to enter the while loop. So while L is less than R. Here we are writing L strictly less than R because we need at least 2 elements. So then we check the sum. So the S is so nums L plus nums R. So if S equals target, so in this case we are done. We are going to return the corresponding indices. So we're going to return nums. So here I want to make some correction. So here is the sum of the course number, and what we are going to return is the index nums are 1. So notice again, we are returning nums L and nums R, the second element, so not returning L and R. So next we check other case. If S is less than the target, and then we're going to increase the sum. So how to do this? We just increment L by 1. In the other case, that is S is too large, so we are going to shrink R by 1. So with that said, then we are going to return. So in this case, actually we do not need to do anything due to the assumption in the problem. That is that only one valid solution answer exists. So once we finish the while loop, there must be something already returned. So now let's check the test case. So here integer object is not subscribable. So let's write this numbers. So here here's the thing. So we are going to use aux and aux and aux. So let's check again. So yeah, so for this this one, so we're going to return 0, 1. So let's change the order a little bit. So let's do this. Let me check again. So we get 1, 0, but this is okay because order is does not matter. So now let's look at the generic case. So yeah, it passes the generic case. So that's about a solution to this problem. This problem itself is rather routine, but what we want to see is that the idea here actually can be used for many problems in different representations and different logic. So yes, for example, the true while loop representation of the sliding window method, so which can include a more complex logics. So it's good to try. And also for this one, we are doing 2 sums. How about we do 3 sums? Can you write a solution using exactly same idea here for the three sum or for four sums and so on. So that's it. Thank you.